alternatives uses this. The limit of f of x as x approaches the 1 from below. And then the other one, the limit of f of x as x approaches 1 from above. And we have to calculate both. Well, we can't make any assumptions, and you can't estimate in your head just like that, right, without trying to calculate them first. You calculate them and then see whether or not you can answer correctly one of the 4 alternatives. Alright, so we'll have a look. Here we are. Try and evaluate the limit of the function as x approaches 1 from below. That means when you're less than 1. Alright, so up here, this is the one we've been looking at. This one. When x is less than 1. This says below 1. This says above 1. Alright, so here we go. Let's have a look. So the limit of the function is going to be the limit of this part. So we'll have the limit now, x approaches 1 from below, and it will be this, mod x minus 1 over root 1 minus x. That's what the function is. That's how it's defined when x is less than 1. This says here we're working with numbers that are approaching 1 but from below. So here's your number log. Here's 0, here's 1. I'm looking at a sequence of numbers that are coming in towards 1 from the left. That's what it means. Okay. Let's see what we've got now. Let's see what we can do with this. Alright, so this is the limit. X approaches 1 from below. Oh. Okay, here we go. We have to take on the mod x. Over here, what have we got? Mod x is equal to just x if x is greater than or equal to 0. And here it's equal to negative x if x is less than 0. Alright, so what have we got? I'll put the 0 in there. 1 here. Alright, so we're looking at this one. So this is x is approaching 1 from below. But you'll see x is still positive. Right, so mod x is just equal to x. So this part here I can replace with just x. And here we've got just root 1 minus x. Alright, now, arguments as before. I can write this as the limit x approaches 1 from below, and write this now as minus 1 minus x. Alright, and underneath it, root 1 minus x. Alright, if we have a look at it here, x is approaching 1. Alright, so by the look of it, if x is approaching 1 and it's approaching 1 from below, x is less than 1. Alright, now we've got 1 minus x down here in the denominator. I'd like to get rid of it. Let's see what happens. Well, from here, if I subtract x, I get 0 is less than 1 minus x. Right, so 1 minus x is greater than 0. It's positive. Alright, now if it's a positive number, what can I do? I can cancel here because this is now the limit x approaches 1 from below, and what have we got? Root 1 minus x into 1 minus x, leave the negative sign, cancel, and I get here root 1 minus x. Alright, now if we evaluate it, what's the limit of this? There's no more work to be done algebraically. X is approaching 1 here. Right, so the limit's just 0. Now, no proper definition for mod x. No replacement here, no solution by the algebra. Right, you need to be able to replace it when it's necessary. Alright, so much for that. Alright, let's have a look at the next part. We'll get this out of the way here. Make myself a bit of space. Alright, now the other part. The limiters, we look from the top, right, above 1. That means we come in this way this time. Right, x is larger than 1. So x is larger than 1. This is the part of the definition that we need for the function. Alright, so now we get the limit, x approaches 1 from above, and we've got this, mod 1 minus x over 1 minus root x. Alright, so just like we did here, mod x got replaced by x, and the algebra simplified, same thing here. I have to work out what the absolute value of 1 minus x is under these circumstances. So let's have a look. Alright, I'll have to go over here. Here we go. X is approaching 1 from above, so obviously x is going to be bigger than 1. Alright, if x is going to be bigger than 1, we've got 1 minus x here. Okay, if I change it, I get 0 is greater than, subtracting x all the way through, 1 minus x. Alright, so here then, 1 minus x is less than 0, and I need to keep that in mind. Okay, so here, I've got the absolute value of 1 minus x. Alright, but the 1 minus x is less than 0. Here, absolute value of x. If x is less than 0, it's minus x. Back here, if it's less than 0, 1 minus x is less than 0, this thing here becomes negative 1 minus x. Alright, so here I can write the limit. X approaches 1 from above. And I've got this now, instead of the absolute value of 1 minus x, this. Minus, and then we've got 1 minus x. All over 1 minus root x. Well, here we are again. This is the difference of two squares. Right, in the numerator. Here's the 1 minus x. So I can write it as the limit. X approaches 1 from the right. Same argument as we had back over here before. I can cancel because I don't have 0 down here in the denominator. This is here, negative 1 minus root x, 1 plus root x. Alright, well you know there's a 1 there. I can cancel it. This time I get the limit. X approaches 1 from above. And I'm left with negative 1 plus root x. Alright, now if you evaluate, as x goes to 1 here, this is root 1, which is 1. 1 plus 1 is 1, it's 2. So it's negative 2. The limit's negative 2. Alright, so now we know a little bit about, right, each of the two limits. Alright, if you look to the very last alternative there, it says the limit from below plus the limit from above is supposed to equal negative 2. What have we got? 0 plus negative 2. Alright, so our solution there, I'll write it up over here. Our limit from below plus our limit from above. Alright, so what have we got here? 0 plus negative 2, it's negative 2, and therefore the answer there is 4.